All right, let's do this. I don't have any idea if anybody ever watches these videos. This one feels like it could be super duper long, so I'll probably break it up. Okay, so this is starting off with something you have to know how to do on your calculator. This would be on the calculator part of the test. In 1995, the population estimated 4 million. It's expected to decrease by 2%. Okay, so decrease by 2%, think about what that means. 0.02, but you have to decrease that from the full 100% of the population. So ultimately you end up with a B value of 0.98, and that is why it's a reduction or a decrease. So equation means I'm going to write function notation. So the function, and you can use x, t, whatever you want. I'm going to use just 4 to represent million, but then I'm going to remember that my answers are in millions because 4 people is a lot different than 4 million people. Just saying. If you have 4 people in your car versus 4 million, that's different. So that's my equation. Notice, friends, it says f of x and equals when it's an equation. What a novel idea. Do it. What was the population in 2001? Okay, so we have to do a little subtractifying because 2001 is 6 years past 1995, which was our start point. So I'll be going to my calculator and I'll be doing, whoopsies, this 6 times over, meaning in 6 years. And when I do that, I get 3.543 million. And since I wrote mine as just a 4 in the equation rather than with all the zeros, I have to write my answer similarly. And then what year will the population reach 2.4? This is the one where you have to use your calculator. We're going to use our big brains. So I don't know the year. The bottom is always time. So my x min will be 0 because it doesn't make any sense. And that's going to really mean 1995. Keep in mind this says what year. Then I'm going to go to x max. I have no idea. And I actually picked a number too small the first time. So I think I have to go out to 30 if I remember correctly. And then think. You have to be thinkersons. You're trying to get to 2.4 million. So that's going to be your y2. And look at the equation that you built. This is a decrease from 4. So 4 is the highest you need to go. So your y is going to go from 0 to probably 5 so that you can see the 4 million. And what I'm expecting is something coming down over time and then this 2.4 line cutting across, and I can look for the second trace intersect. So I type in the equation from 1a as y1. I type in 2.4 as y2. I go from 0 to, for the x's, I go from 0 to 30 is what I think I ended up having to use. And that's for my x's. And then for my y's, I only went from 0 to 5. And that's representing millions. So I found that the place that they intersected was 25.28. But you have to add that into 1995 because it asked what year. So if you add 25 to 1995, you're going to end up in the year 2020. Oopsies. Nobody's favorite year. But that is the answer to the question. Sad face. All right, so same process. When you have something new to look at, you will need a new window. Window is the key. Okay, this one's a little tricky because it says it's the time to double a certain bacteria, meaning you have a B value of 2. You are doubling it, multiplying it by 2. You're starting with 100, but it only doubles every 2 hours. So to write an equation, I'm going to be saying, okay, my initial value is 100. My B value is 2 because it's doubling, but I'm going to take my time and divide it by 2. My hours has to be divided by 2 because it only happens every 2 hours that it doubles. So if I have 6 hours that have passed, 6 divided by 2 means it will have doubled 3 times. So what about after 3.2? So I'm going to my calculator and I'm entering this in, 3.2 over 2. And if you need parentheses around it, because your calculator does one of these numbers, but then just shows 3.2 divided by 2, you have to tell your calculator that that's all in the power. If you have a fancy pants calculator, it'll show it up in the power, and that won't matter if you have the parentheses or not. Okay, so there I'm coming up with about 303. Now this one doesn't tell me what decimal place to go to. On the answer key, it looks like I went to 2 And then it's saying how many bacteria. So that's bacteria. Yum. Okay, here we go. Part C. How long will it take to get to 450? So again, you're going to need a line cutting across at 450. Use your big brain. You started up here in this equation with 100. So if this is 450, you started down here at 100. This is going up because it's doubling. This is the point in question. Think about your window. So again, I don't really know how far I have to go ever. So I'll know my X min to be 0 because I'm starting with 0 hours. And if you take a look back here, after 3.2 hours, it was at 303. So it's not going to take forever to get to that 450 that they're asking for. So I think I went for my X max. I think I went to like 5, 6, maybe 10. And then my Y over here, my minimum can be 100-ish. And my maximum, I guess I would probably go to like 500 because I want to be able to see clearly the 450. I don't want to stop right at that. And so then when I do that as my window, I'll see something similar to what I drew, but probably better. And then my 2C answer comes out to be 4.34 hours. And our answers should be identical if we are entering the equations in properly. All right, more bacteria. Yay, it's currently 2,000, increasing by 4% every hour. Okay, so it's happening every hour. We won't need to mess with the time. Now be careful. This says to write an equation, find the population in T hours. So it's telling you that this function is supposed to be using T. My initial value, since I now have 2,000, is 2,000. And because it's increasing, I'm going to add that 0.04, meaning add the 4% to my existing amount. So 1.04 to the T becomes my problem, like my function. What will the population, and now this one says, if it says, then do what it says. Accurate to 3 decimal places, be in 3 hours. So I'm going to take my 2,000, my 1.04, and I'm going to raise it to 3 hours. So that one's like the pattern is that you're just plugging in, find the equation. Part B is to plug something in for the X, and then part C is to use your calculator to kind of find that unknown time. So there's my 3 decimal places, and I'm looking for bacteria. In how many hours, and again, accurate to 3 decimals, will it be 4,000? So think about your window. Time goes from 0 to I'm not sure. I'm going to cheat and pretend I don't know the answer, but I'm going to go to 20. So my X min is going to be 0. I might have to ding around with this one, but ultimately I ended up with a max of 20. The scale doesn't matter that much. Whatever you choose to count by is fine. Water break for Hadeen. Okay. My equation up here. This is going in as Y1. Y2 is going in as the 4,000. So I know I need to be at least as high as 4,000. Started at 2,000. And so I would probably go from 0 as my Y min. You could certainly start higher than that as long as it's 2,000-ish. And then my Y max, I chose to go to 5,000. And if I'm going from 0 to 5,000, I'd probably count with a scale of like 500s or something like that. Anyway, it's going to draw that in, and it's going to show where they cross. Keep in mind that if you guessed on your X max and your window only shows this much, then you just have to extend your X max so it goes out farther and you can actually see the point of intersection. And when I did that, I got 17.673, and I'm writing it out to the 3 decimals because it says to do that, and I'm labeling it because it's a word problem. Okay, so surprisingly, these next 3 are going to be exactly the same. So a trust fund has a current value, therefore A, of 25 grand. It's being used, so this is going down at a rate of 3%. So 1 minus 0.03 gives you a B value of 0.97. It's decreasing. They're losing it. It's getting used up with no additional interest. Write the equation to find the value in terms of T. So F of T is my initial value, 25 grand, 0.97 less than 1, so it's going down per year. So that's my T value. What will it be after 25 years? To the nearest cent. So I'm going to just round to 2 decimal places. So this is not surprising since all the part B's have been the same. I'm going to go ahead and type in my equation with that X filled in with a number. And when I did that, I got money, 11674, and then 37 cents. Here, this one says accurate to 3 decimal places. And keeping in mind that you started at 25,000 and decrease over time. So that needs to be your max, and then they're asking for 15. So my Y2 is going to be 15,000. My Y1 is going to be that initial function that you wrote. So you got to be careful writing your function because that's related to part B and then part C. So I ended up with this probably going from an X min of 0 to, I don't know, I usually try 20 as my max and then see if that's too big or too small because this is the one that you don't know. That's what you're looking to find. And then my Y's, I went from a Y min, you're only going down to 15,000, so you could go to a Y min of like 10,000 and then use 25 as your Y max. That would be okay. And you could count by a scale of 500s or 1000s. Either way, you're going to see this point, and then second trace, enter, 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 and I got 16.771 years. And this one said in how many years, not when like the other one or during what year. So this whole first page is really practicing your calculator. So since there's an entire page dedicated to it on the review where there's a part A, B, and C, where in part A you write the equation to represent the situation, and then in part B you plug in an X value, and then part C you figure out when it's going to hit a specific value by using your calculator, I think it would be a safe bet that that's what it's going to be like on the test. It's time to switch colors. Okay, let's go green. We're going to graph. So pay attention. We learned 2 different kinds of graphing. This is exponential, exponential, but these are not. These are log, log. You have to have a conceptual idea of what each thing looks like. This is the general parent graph for exponential growth when b is greater than 1, and its inverse is this. So if this is some b to an x, this is the graph of log with that same base. Logs and exponents are inverses. They are squares and square roots, cubes and cube roots, adding, subtracting. They are inverses, math opposites. So you should know a few things, like think about what you know. With this general shape for exponentials, the domain is always all real. So on the test or quiz, I'm going to go ahead and kind of think about that. Keep in mind that in switching from exponentials to logs, my domain from exponential becomes my range for logs, which means these will have always all real answers. So that's because this one, the log goes down forever and up forever, so it has an unlimited range. This one goes to the left forever and to the right forever, no matter what changes you make, so that has an unlimited domain. Okay, the range and the asymptotes. Keeping in mind that exponential has a horizontal asymptote at the D value in the problem, and the log graph has a vertical asymptote that's changed by the C value. This one's pretty basic, 3 to the X. So that's going to have that horizontal asymptote at 0. That is a part of your graph and should be visible to me. The graph is going to be located above because there's not a negative. So it's going to go from 0 to infinity for a range. And the horizontal asymptote is going to be located at y equals 0. And I can't say any more times that it's important to write that as a horizontal line. So y equals 0. On the test, it's going to ask you for specific points. So you're going to need to think, okay, and exponentials will be easier for you because you're more used to them. Like if I did 3 to the 0, plugging in a 0, I probably shouldn't write that there. That'll be confusing. If I use an x value of 0, I'm doing 3 to the 0, which is 1. If I did x to the 1, I'm doing 3 to the first, which is 3. And if I used a -1, I'd have 3 to the -1 power, which is a third. So at -1, I'm at a third. At 0, I'm at 1. At 1, I'm at 3. And that all goes with what I expect to see. And so I have my 3 points, I have my domain range, asymptotes, everything's hunky-dory. This has the same base, so it should have the same shape. But this up in the top is like being in the container, and it's actually going to move it to the right 1, and this is going to move it down 2. Down 2 is significant because that is going to change my horizontal asymptote to y equals -2, and my range is going to get pulled down with it because my graph will go to wherever that floor is. And if the floor is at -2, the graph will follow. I'm going to plug in some numbers and try to make my life easy. Let's say I plugged in a 0. What would you have? 3 to the 0 minus 1 and then subtract 2. Well, that's going to be 3 to the -1, so a third. And a third minus 2 is going to be -1.6 repeating. And then if I plugged in a 1, I'd have 3 to the 1 minus 1, so that would turn into 3 to the 0. But 3 to the 0 is 1. 1 minus 2 is -1. And if I put in a 2, I'd have 3 to the 2 minus 1 power, or 3 to the first power, which will be 3 minus 2, which is 1. So you kind of got to noodle your way through those 3 points, but you also know what it should look like. So at 1, I'm at -1. At 0, I'm at -1 point something or another. And at 2, I'm at 1. That'll make sense to me because that looks like it should. It has a base that's greater than 1. It should go up from left to right. It should be moved to the right 1 and down 2. So it's been shifted around a bit. Okay, now you have to think your way through what's going to change when you go to do log graphing. This is a basic log base 3 graph. So the vertical asymptote's just going to be right here. There's nothing that's moving this graph left or right that would impact that. So my domain is going to go from that vertical asymptote up to infinity. And that asymptote is going to be located at x equals 0. Really important to pay attention to whether it is horizontal or vertical, because that's going to determine whether you're writing y equals 0 or x equals 0. Now, for some of you, this next part of finding the specific points is going to be the tricky part without your calculator. And there is one of each kind of graph on the no calculator part. One log, one exponential. Whoopsies. So let's think about how to pick smart numbers that make our life easy. This is asking 3 to what power is going to equal x. That's what that's asking. So when I go in there to put my values, first of all, I can't use anything, I can't use 0 because it's on an asymptote. So I try 1 to the right of the asymptote. So I'm plugging in a 1. So that's saying 3 to what power equals 1? Well, 3 to the 0 power would equal 1. So 1, 0 is one of my points. Then I don't want to try a 2 because the question would be 3 to what power is 2? So I try something like 3. Because then the question becomes 3 to what power is 3, and I can get a nice pretty answer. And at 1, 2, 3, I'm at 1. You might even try something like a third, because 3 to what power is a third? The answer is a nice pretty number of -1. So at a positive 1/3 for x, I'm at -1 for y. And all of those points make sense given what I expect to have happen in a log graph. All right, then what's this part going to do? This is going to move it to the left 1. That's going to be essential because that's going to affect my asymptote, which is going to affect my domain. And then it's going to be up 2. So I'm going to draw in a vertical asymptote, move to the left 1 from where it's normally located. So that'll be at x equals -1. And so I know my domain is going to go from that value off to infinity. Okay. Now I got to find my points. And again, this is going to take some big brain choosing. because this part is going to be tricky for me to go through if I don't feel confident. So I always start 1 to the right of the vertical asymptote because that just works for me. So I'd be at log base 3, like I'm plugging in a 0, because that's 1 to the right of my -1 asymptote. So that if I put in a 0 here, this turns into log base 3 of 1 and then plus 2. This is asking 3 to what power is 1. So this whole part has a value of 0. So that's gone and I get a 2. So 0, 2 is one of the points on my graph. Let's say that I tried a 1. I don't want to try a 1 because I'll end up with log base 3 of 1 plus 1, which is saying 3 to what power equals 2. I don't know how to do that without my calculator, so I'm going to pick a number that makes more sense. I'm going to plug in a 2 because this will turn into a 3, and I'll be asked log base 3 of 3, which is saying 3 to what power is 3. So that's 1 plus 2, and I get 3. So at 1, 2, I'm up 1, 2, 3. So you're just trying to choose your numbers wisely so that this part that's inside of the parentheses is a power of 3. Like 3 to the first was 3, 3 to the second would be a 9. You'd want to pick an 8 maybe for that, because 8 plus 1 would be 9, and you'd be like log base 3 of 8 plus 1 means log base 3 of 9. That's saying 3 to what power is 9, and your answer would be 2 plus 2 is 4. But that's way off the graph. So here, excuse me, here I know what it's supposed to be shaped like. I'm not surprised that it's up higher and to the left because that's what I anticipated based on the numbers. Okay, getting super tired of graphing. You are too, probably. This is exactly the kind of thing, like these two are really good examples of what you should expect to see on the test. So stop, think, and go, okay, this is exponential. What do I know about exponentials? I know that the domain is all reals. I know that there's a horizontal asymptote typically at 0, but this one's getting moved down 3. So negative 1, 2, 3, I'm going to have me a horizontal asymptote, and its location is going to be at y equals negative 3. That's going to drive the range down with it. And so I'm all set to go on those 3 things that the test will ask me about. Then I'm going to try some numbers. I'm going to try, I don't know, 0. 5 to the 0 is 1, minus 3 is negative 2. Then I'm going to try 1. 5 to the first is 5, minus 3 is 2. So 0, negative 2, 1, positive 2. So that goes up really fast, but it kind of makes sense because my base is a 5. That's a really big growth factor. So you have to know what to look like, what to expect. Don't let your line touch your asymptote. Have it scoot up here, and then look how fast that goes up because of that B value being a 5, which is a pretty big number. Okay, then over here, this is going to be the inverse of that, meaning it's going to be the sideways version because it's base 5. This one is moved to the right one. So when I am thinking about how that affects my graph, I'm going to look at it and think, okay, normally for logs, my range is always all reals, but normally my domain follows that vertical asymptote. If you move the graph to the right, your vertical asymptote is going to go to the right. And then that's going to take with it. So my asymptote's vertical, and it's going to be x equals 1. That's going to take with it the domain. And then I'm going to try some numbers. But again, I'm going to try some numbers that make my life easy. Let's say that I tried a 1. Then I would have log base 5 of 1 minus 1, which is a 0. So then be asking 5 to what power is 0? Oh, that was dumb. First of all, there is no answer to that. And the reason there's not an answer to that is that's the location of my vertical asymptote. So I'm going to use my big brain and do what I always said I did, which is start 1 to the right of the vertical asymptote. So now I have log base 5 of 2 minus 1. So log base 5 of 1 is saying 5 to what power is 1, and the answer to that is 0. But then I want to pick a number again so that what's inside here is easier to manage and is a power of 5. So my next number that I'm going to try is I'm going to plug in a 6 because 6 minus 1, when I plug that in, will turn into a 5. And the question will be 5 to what power is 5? So then at 2, 0, and 1, 2, 3, 4, 5, 6, 1, I get my 2 dots, but I already know that it's going to look like this. It's going to be really steep once it starts to go because it has that log base 5, just like our 5 to the power did. So this is asking for the asymptote, and it's asking here for the asymptote as well. I wrote the rest of the information as well because that's what the test is going to do. Okay. So, holy moly, look at all these questions. I bet this was fun for you. But these are going to go pretty fast. So, give the domain of each. Okay, think about that. Domain, when you're doing logs, is tied to the vertical asymptote. So, my domain here is going to be tied to the fact that this went 2 to the left. My asymptote's at -2, and so my domain will follow. This is a D value, and we'll move it up and down. It does not change my vertical asymptote. That'll stay at 0, so my domain will stay at 0 as well. These, however, are exponential. Exponentials always, always, always have all reals because they are not limited from left to right. They are limited from bottom to top. Rewrite the equation in exponential form. Okay, so this is just where you're going to take the base to the power equals the answer. You should result in a true statement. So that's true. 36 to the 1/2 is the same as the square root of 36. So that's a true statement as well. Start in the basement, go get the police, come back around. 3 to the -2 does indeed equal 1/9 because that negative power would move the 3 squared into the denominator. This one doesn't have a base stated, so that makes it base 10. So 10 to the 4th does indeed equal 10,000. So you're not actually doing any math. You are literally just rewriting this. ln implies base e, so I would write it as e squared. And the reason this is a squiggly equal sign is that you are dealing with an irrational go on forever number like pi, so you're not really giving the exact value to e squared. You're giving an approximation. Here you're doing the other thing. These are kinds of problems that you would be doing on the no calculator part of our quiz. So I go log, and then the base always goes in the basement. The power always goes to the right, and then this other number's here. So when I write this one, it's the log, the base goes in the basement, power to the right of the equal sign, and then the other number goes here. Log, base goes in the basement, meaning the thing that's raised to the power. The power goes to the right of the equal sign, and then your other number fits in here. This is a log base 10, but I'm not going to write the base 10 because it's common log. And so I write log base 10, which is invisible. And then I put the power to the right, and the number gets stuffed in there. This is going to be an ln. So I don't write log base e, I write ln. The power still goes off to the right, and then the 5.5 is here. Technically, that should be wavy, but who cares? Okay, evaluate means I need to find a number, and this is without using your calculator, so this is good practice. So what does this mean? This is asking 5 to what power is 1, and 0 is my answer. 2 to what power is 8, because they don't write equals what all the time with logs. It's sort of implied. So then I use my thinker, and I come up with 3. The next one is 3 to what power is 27. So I think on that for a little minute. Here I have to slow my thinker down because this is saying 4 to what power is 2. So you have to resist the urge to say 2 because that's not true. The number is getting smaller. And so you have to take the square root of 4 in order to get 2. And we have to think of it as a power. So you again have to remember that square root and 1/2 power are the same. So 4 to the 1/2 power makes that value go down to a 2. 5 to what power is 125? So there. 2 to what power is 1 over 8? The fact that it went into the bottom means it's a negative, and 2 became an 8, so that's cubed. Here the number got smaller again because this is 25 to what power goes down to being a 5. Well, you'd have to think, well, that's a square root to get that. But we don't write it as a square root. We write it as a fraction power. So a half is my answer. 3 to what power is 3? 1. This one is more implied because there's no base written, but this is asking 10 to what power is 10? So 1 again. And again, this is implied. This is log base e of e to the 5th. So you can think of the undercut, or you can just think this is saying e to what power equals e to the 5th. No matter how you get your way through that in your mind, that's going to land you at a 5. Using a calculator. Okay, well, I can do that. You literally type it in. So I'm sure you don't need help with this. Type it in, type it in, type it in, and type that in. Make sure you're using the LN button when it says to. Those of you who do not have the calculator where you could type them in, you use the change of base. You do the log of the 48, close that out, and you divide it by log of 7. And when you do that, you should get 1.989. Here you'd have log of 100 over log 2. And when you do that, you get 6.644. Okay. So now we have to pay attention to our verbs. This is going to get into the properties, expanding in simplest form. So you're going to spread them all out. So this is because these are joined by multiplication. I'm going to have log x plus log y. In an expansion, everybody should have a log and there shouldn't be any powers. Here I'm using my second property to say the log x would be, and then subtract log y since that's on the bottom. Here I have kind of two phases. I keep the base, whatever that is, and then I'm going to separate these by subtraction because they were put together by division, but you can't have powers up top in your expansion. So I end up with 2 log base 2x minus 3 log base 2y. So don't forget to keep that base throughout your problem. Okay. Before I get started on this one, I'm going to think of this bottom as z to the 1/3 because I need powers, not roots. So I have ln of this top one, and then I add the ln of y squared because that's also on the top. Then I subtract the ln of z to the 3rd because that was on the bottom. But all of these powers need to drop down. So 3 ln x plus 2 ln y minus 1/3 ln z is my complete expansion. Okay, now I'm going to do the math opposite of that. I'm going to go ahead and condense. So it starts off pretty easy. These are separated by adding. When you condense, you should have log or ln written one time. And so these go together. You can put parentheses or not. It doesn't really matter. Here, before you can pack up, you got to get rid of these powers, and the only other place they can go is up top. So I've got that going on, and then this. So I'm going to write log base 3 one time, and then it's going to be x squared on the top, y to the 4th on the bottom, since that follows a subtraction. And again, if you're feeling parentheses-ish, go ahead and throw them down. This one looks messy. Yuck. So I'm going to go ahead and move this up here. So I'll have ln x cubed. Here, that's going to go up there. So I'm going to leave this for now. I'm going to have ln y squared. And then I'm going to have plus ln z to the 4th. Well, we're going the opposite direction now. So this is going to end up being 4th root of z in my answer. This subtraction is telling you that everything after that should go into the bottom because you're basically distributing it to both pieces. So they're both following a negative because of the parentheses. So I'm going to have ln written one time. I'm going to have my x cubed up top, the y squared and the fourth root of z are all going to be on the bottom. And so again, you can use parentheses or not. So the difference here is that the parentheses are the reason that everything after that follows or gets the negative, and therefore everything goes on the bottom. Okay, know how to do this. Use log 2 equals A and log 3 equals B to evaluate in terms of A and B. Now this can be on the graphing calculator part because you can't use a calculator, you have to use your brain. So what that's telling you is you don't have any information about 6, so you can break 6 down into 2 times 3, and then that would separate by addition. And so they're asking you to say, oh, okay, well, that will turn into A plus B. I didn't even write them in terms of A plus B on the answer key. Sorry about that. I'll go back and do that. Here, I'm going to have the log of, I need to write 9 in a way of 3's and 2's, so I'm going to write probably 3 times 3 or 3 squared. That can drop down in front, so it'll be 2 times log 3, but log 3 is b, so it will be 2b. Here, I'm going to have log of 2 minus log of 3 because they are, excuse me, because they are put together with division, I'm separating them with subtraction. And so using my information from here, I'm going to call that A minus B. Ooh, this one's tricky. So this is going to be the log of 3 over, and you can think of this a couple different ways. That would be 2 to the third power would be one way. So now I'm going to have log 3 minus log 2 cubed, but that's got to drop down in front. So then I have log 3 minus 3 times log 2, but that's going to turn into log 3, which is B, minus 3 times log 2, which is A. Okay, and then this last one is similar because this is going to be the log of 1 over 2 cubed. So log 1 minus log 2 cubed, drop that down, log 1 minus 3 log 2. Okay, that's confusing because you don't have a 1, but keep in mind that this is going to be saying anything, like whatever base it is to what power equals 1. Anytime you have that, this part becomes a 0 because whether it's a 2 or a 5 or a 7, you're saying what that number to what power equals 1. So you end up with 0 minus 3, and then log 2 is A. And so I'd have 0 minus 3a, and so I would just write my answer as negative 3a. I just must have brain farted that onto the, oh, is that the end? No way. At the very end of it. So I'll go on and change the PDF that's posted online. So that was super fun, and I'm sure that you found it very entertaining. It's kind of weird because no dogs barked, but whatevs. I hope you do awesome and that you round this quarter out with a super great, fantastic, just stupendous quiz score. See ya.